Hello everyone. Today our video is on normal distribution and we will be discussing about a normal distribution. Now in my previous videos, I've already discussed about binomial distribution and that was a discrete probability distribution. Now the normal distribution is an example of a continuous probability distribution. You should have a slight idea about probability before watching this video. So I would suggest that if you do not have an idea of probability, you should go and watch the basic probability video of Pengrow, right? So you will see the link in the description, right? Now, what is a continuous random variable? We have discussed this in our previous videos, but I would just like to reiterate that it is a random variable which can take value within a range of infinite values. Like, for example, height, weight, shoe size, all of these things, they cannot occur in clear steps. They can go up to decimals and it's better to put them up in a range, right? So a continuous probability distribution is a distribution in which the random variable x is actually continuous. We just discussed about continuous, right? So at one point, the probability of x is equal to k. Let's say x is equal to 1 or x is equal to 2. That would be 0, right? For any value because it's not occurring in a clear step. It's a range. You need to define a range in the probability. It can be probability of that x is less than equal to a or and greater than equal to b. It can be like this. It has to be a certain range. So you need to understand that it has to be a certain range, and a probability distribution, it can be represented by a continuous graph. The probability density can be on the vertical axis, x values on the x-axis, and you can find it like this. So the probability, if the probability density is on the y-axis, the area under the graph, the areas of the rectangles, that would be the probability. And all the areas will sum up to 1 now. Okay. Also, one more thing you need to know in normal distribution, if it is probability of x is less than equal to k and probability of x is less than k, it's the same thing. In binomial, it was different, right? You either add that probability as well or you don't. But for this, it is the same, right? Okay. Now, what is a normal distribution? It is a continuous probability distribution. We already discussed this. It is symmetrical on both the sides. That means it will give you a bell shape. It will give you a shape like this. We are going to discuss this in detail, right? It is denoted by x follows a normal distribution. This is your mu, the mean, and your variance. This is your standard term, right? So if the mean changes, then the graph will translate horizontally, right? Because the mean represents basically the maximum. This is your, this will be your mean, the maximum. If mean changes, it increases. The graph simply translates. But if the spread of the data, the variance changes, that will change the spread of the graph. In this case, your mean, you can see, has remained the same. But now the values are more spread from the mean. When the values are more spread from the mean, this means the variance has increased. So a large variance will lead to a wide center. And a small variance will make it narrow. This has made it wide, and here it was narrow. And here it is wide, right? All right. Now, mean and variance, two important things we've already talked about. And one more important thing to know is that in a normal distribution, your mean, mode, and median, all three are same because it is a symmetrical distribution. Right? And the normal distribution curve is 2 points of inflection, basically, mean plus standard dev and mean minus standard. Okay. At both of these points, why is that a point of inflection? At both of these points, your probability will be the same. Right? Okay. There are some other properties. Approximately 2/3, that means 68% of the data lies within one standard deviation. Approximately 95% of the data lies between two standard devs of the mean. I'll show you the pictorial form of this. And nearly all of the data, that is 99.7% of data, lies in three standard devs of the mean. Okay. And then first, let's look at the diagram. So you can see 68% between one standard dev, between two standard dev, 95%, 99.7% between three standard devs. There is one more important thing as well, and that is the Z-score, right? It can be calculated. It actually measures how many standard deviation you are away from the mean. That X value is away from the mean. So you've taken the X value minus the mean, you divide it by standard dev. So if Z comes out to be 2, it tells you that you are 2 times away from the mean. If Z comes out to be -2, that means you are 2 times away of the mean on the, sorry, it should be a normal one. You're 2 times away from the mean on the left side. Here is your X value. Let's say 2 times of the standard deviation away from. +2, 2 times of the standard deviation away from the mean on the right hand side. Now, modeling through normal distribution. Now, you can use normal distribution to, model. A lot of real life examples can be modeled into a normal distribution, right? Provided that your data is large enough, your variable has to be symmetrical. There has to be one mode, obviously, because the mean equals to the mode equals to the median. Okay. Now, for a normal distribution, X can take any form of real values. Values which are very far from the mean, more than like 4 standard deviations, they will have a density of practically 0, because we assume that in 3 standard devs, most of the data will be covered. Right? Variables which have more than one mode or no mode, they cannot be modeled using normal distribution, and variables which are not symmetrical, they can also not be modeled using normal distribution. So this was about normal distribution, and in the future videos, we will cover more such distributions. Thank you.